I recently made a video about the fact that if you order Premier League teams by the number of Premier League title wins, then you get the beginning of the Fibonacci sequence. And somebody commented, so it's just a random sequence of increasing natural numbers whose sum is 33. By the way, notice that this person said increasing. I don't know if they're trying to push my buttons because the sequence starts with 1, 1. But in any case, they are right that it's just a random sequence that adds up to 33. So they wonder what's the probability of getting that specific one, assuming they're all equally likely. And I said, we can figure that out. So what we need is to figure out in how many ways we can write the number 33 as a sum of positive integers. And that's what in mathematics or in combinatorics we call an integer partition. We're looking for the number of ways in which we can write the number 33 as a sum of positive integers. By the way, the topic of partitions is a very classical topic in mathematics, and there is a lot of research about the partition function. For example, Ramanujan did a lot of work about that function. So, for example, if we were trying to do this for the number 4, we can write 4 as 4, or 1 plus 3, 2 plus 2, 1 plus 1 plus 2, or 1 plus 1 plus 1 plus 1. So there are 5 ways to write 4, so the number of partitions of 4 is 5. And for 33, we can write it as 33, or 1 plus 32, or 2 plus 31. Then you do all the ones with 2 components, with 2 numbers. Then you go through all the ones with 3 numbers, and so on, all the way up to writing 33 as a sum of ones, except that we don't want to write it as a sum of 33 numbers, because here in the Premier League, there's 20 teams. So we want partitions of 33 up to 20 numbers. Now, there is also a name for that in mathematics. Those are called restricted partitions. For example, we can try to figure out in how many ways we can write the number 33 as a sum of 5 integers, or 10 integers, or as a sum up to 20 integers. And that's what we want to find out. And then I went to my favorite algebra system. In this case, is called Magma, which can compute restricted partitions. This function computes how many ways 33 can be written as a sum of exactly n numbers. And then I added all the possibilities as a sum of one number up to 20 numbers and see what the total is. And it turns out that the grand total is 9,871. What that means is that the chances of landing on the sequence, on the Fibonacci sequence, when ordering those titles was 1 in 9,871, which is something like 0.01% chance, which is tiny. So should we go back at this and be really surprised that this happened and maybe start thinking that maybe there is a reason why the Fibonacci sequence appeared? And the answer is no. It's just purely a numerical coincidence. And just because something had a very low chance of happening, it doesn't mean that there is some higher power or higher explanation of why this happened. It's just a numerical coincidence. There would have been many other possibilities that would have made the news for one reason or another. For example, if Manchester United had 33 titles and everyone else had 0 titles, that would have made the news. Or if everyone had 1 title, that would have made the news. And many other ones our brain would have recognized as some pattern, and somebody would have written a news article about it. But there are many other ones that are just garbage combinations that nobody would have made any big deal out of it. For example, last year, it was not a Fibonacci sequence, so nobody made a mention of it, or as far as I know, any previous year in the Premier League, it wasn't a Fibonacci sequence. Maybe the very first year was a Fibonacci, or the beginning of a Fibonacci sequence, but otherwise, it hasn't been, so it hasn't made the news. In any case, don't underestimate the power of our brains to find patterns in places where it's just a coincidence.